folks, welcome back to another video. Today we're looking at question 245, shortest word distance 3. The way that we'll be approaching the problem is by iterating through all of the words in the list, and we'll keep a track of the index when we see a word of interest, which is basically word 1 or word 2. And once we have an index set, anytime we encounter the word again, we'll compare the current index with the index that we have stored already and see if they hold the conditions to calculate the minimum distance. So let's get started. The few things that we need are as follows. We need int n, which is the length of the array, words dictionary dot length. The next thing we need is the minimum, which would be the answer. And in this case, we can just set the minimum to n because we know it is guaranteed that both the words that are given to us will be in the list. And the other thing that we need is like the previous index that we've seen. And let's set this to -1. Awesome. Once we have it set up, we can iterate through the entire array. So int I equals 0, I less than n, I plus plus. So if the current word, so words dictionary I, if it is equal to word 1 or word 2, we know that we have to do something. So let's just create that if condition. So if both of these are equal, we need to do something. But in the very end, we know that we have to update the index to I, right? So let's do that regardless. And oh, right, this should be here. Yeah, that should be here. And once those are equal, we can compare the values with the previous index only if the previous index has been set. So we check that the previous index is not equal to -1, right? And there are other two conditions that we need to check. What if the previous index that we've seen is the same word that we're comparing it with, if the words are different? So there are two conditions, right? So only if word 1 dot equals word 2, or if the words of dictionary at index I is not equal to the one that we've seen at that we're seeing at index. So what exactly does this mean? It means that if both of these words are equal, that means we can compare the indexes. But if they're not equal, we just want to make sure that since we are calculating the minimum distance, we're calculating between A and B and not between A and A or B and B. So that's the reason why we're adding this condition. And once we know that this condition holds, then we can calculate, let's minimize this to make it a little neater and easier to understand. Then it would be minimum would be equal to mat.min of the current value that we have and I minus previous index. And my bad, this should have been set to previous index I. And this is previous index as well. I wonder if I made the same mistake elsewhere. Let's see. I think that should be good. And in the end, we would just return the minimum. I think that should be it. Let's try compiling this. Okay, where did I go wrong? If word 1 equals word 2 and word dictionary at I is not equal to, oh, and this is not or, this is and. Both of these conditions should hold. Let's try that again. Okay, cool. The first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity of the entire solution is of n since we are iterating through every single word in the world's dictionary. And the space complexity is of 1 since we're not using any additional space, we're using only constant space right here. Amazing. So that's how you solve the problem. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I would really appreciate that. It keeps me motivated to make more videos. Thanks so much. I'll see you folks soon. Peace.